We're going to look at comparing experimental and theoretical probability next, but we're going to do a quick warm-up here where we're going to practice some of our theoretical probability skills. Okay, so we're going to take a situation where we have a six-sided dice. We're going to toss it. Okay, and then we're also going to take two coins and we're going to flip both of those coins. So we want to determine the probability that that we're going to get a number that is less than 3 and exactly two tails turned up. Okay, so we actually have three things that we need to look at. First, we're going to flip that dice. Okay, and so when we flip the dice, we can get a number that is either a 1, a 2, a 3, a 4, a 5, or a 6. Our second situation that we need to look at is for flipping heads and uh, coins, and the third one we're also flipping some coins. So if we make our tree diagram to map out all of the theoretical possibilities, we could get this piece. Okay, now I'm only going to complete sections 1 to 3, or complete this chart for uh, the coin toss or the dice toss 1 to 3 because we're looking for a number that is less than 3. Okay, so let's say I roll a 1, and then I'm going to toss my first coin. So my first coin toss, I could either get a head or I could get a tail. If I roll a 2, I could get either a head or a tail. If I roll a 3, I could get either a head or a tail. Okay, same thing with 4, 5, 6, etc. Okay, if I flip the coin a second time, I could get either a head or a tail. If my first coin was a tail, and I flip it a second time, I could get either a head or a tail. And so on and so forth. So head, tail, head, tail, head, tail. Okay? So each time that I roll a number, let's say, so if I roll a 1, there are ultimately 4 possible end pieces or end results that come with that. I could get head, 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 tail, tail, head, tail, head. Okay, so there's actually 4 possible numbers for each, 4 possible outcomes for each individual roll of the dice. Okay, and so since there are 6 rolls of the dice and 4 possible outcomes for each one of them, there's actually 24 outcomes in total. Okay, and so I'm not actually going to complete the chart for all 24 outcomes, but we need to know that there are 24 outcomes in total. Okay, so now what I'm going to do is I'm actually going to map this out. Okay, so let's say I rolled a 1, then I got a head and a head. I rolled a 1, you get a head or a tail. I rolled a 1, I got a tail and a head. 1, tail, tail. Okay, then I rolled a 2, and I got a head and a head. I rolled a 2, got a head and a tail. 2, tail, head, 2, tail, tail. And then you could also do it for 3. You get head, head, 3, head, tail, 3, tail, head, 3, tail, tail. Okay, so our situation here, we need a number that is less than 3. Okay, if it's less than 3, that means that it could be either 1, 2, either, yeah, the only numbers here that we have that are less than 3 is either 1 or 2. Okay, so we can't even use the bottom part here. Okay, so we can't use this particular piece because those numbers are all less than 3. Okay, so we also need exactly 2 tails that are turned up. Okay, so I've got a 1 and a tail tail here, and here I have a 2 and a tail tail. Okay, so that means that I have 2 situations, okay, where I actually have the 2 out of my 24 situations result in getting a number that is less than 3 and 2 tails. So 2 over 24 is the same as 1 over 12, and I can figure this out and convert that into decimal. So 1 divided by 12 is equal to 0.083, and 3 is repeating, which is the same as approximately 8.3%. Okay, so that's just a quick review of the theoretical probability and using a tree diagram to help plan that out. That one's a little bit more complicated, but the same principle applies.